Welcome, everyone. This is the second webinar on chemistry career pathways sponsored by the UPLB Chemical Society alumni in cooperation with the Institute of Chemistry through the Elementa project. I am Leilani Mercado and I will be the moderator. This webinar series is a career orientation program for college students, chemistry and non-chemistry majors, fresh graduates, high school students exploring various career options in higher education, parents, professionals. It's for everybody. We invited alumni members from different sectors of the chemistry employment world to share with us their experiences. In the first webinar, Dr. Joey Santos related his journey in the academe as he became a university professor. And Dr. Isagani Padulina talked about organizational leadership in the chemical industry sector. Today, our two speakers will share their experiences in laboratory management in the academe and innovation in an industrial setting. We would like to remind all the attendees that questions will be entertained after our two speakers are done. Meanwhile, you may type your questions in the question box. Our first speaker is Dr. Earl Ada. Born and raised in Los Baños, he stayed home and earned a Bachelor of Science degree in chemistry from UPLB in 1985. He was an active member of Camsock and the UP Vanguard Corps of Cadets. Earl worked as a research scientist at the National Institutes of Biotechnology and Applied Microbiology, or Biotech. He then took on international industrial positions at Saudi Petrochemical Company and later on at Hong Kong Standards and Testing Center. In 1992, he went to the United States for graduate school and earned his doctoral philosophy degree in analytical chemistry from the University of Illinois at Chicago. In 1998, he did more research as postdoctoral fellow at the University of Houston in Texas. So with all the laboratory experience he gained, he then became a manager of the Surface Science Laboratory of the Central Analytical Facility at the University of Alabama in 2002. And in 2006, he joined the University of Massachusetts Lowell, where he is currently the director of Characterization Labs of the Core Research Facilities Program. It is notable that Earl is married to another Camsock member, the former Lourdes Rosella Pascua. Please welcome Dr. Earl Ada as he shares with us his experiences, thoughts, and insights about career pathways in chemical laboratory management in the academic setting.
Hello. Magandang umaga po. Tuloy po kayo. I'm so happy that you are able to come and visit with me here at the University of Massachusetts here in Lowell. And my job as director not only requires management of the laboratory, but I also interface with the clients and perform analytical services for them and consult with them in various aspects of their research. So today, I'd like to show you a little bit of what I do. So I'm going to pan the camera at various places just to show you the instrument of interest. This is a scanning electron microscope that allows us to magnify very minute images down to about a nanometer in size. And for today, we're going to look at a specimen that I had received from a client. And these are bioceramic pins that are bioresorbable, and these are used in the manufacture of devices that go into the human body and used to fasten broken bones or ligaments, for example. And I have a set of pictures here in my display that shows you the actual applications. Now, what I have here in my hand would be a pin that is the sample of interest. They had fractured this surface, and they then want to understand what is the microstructure of that surface in relation to the mechanical and physical properties. So I'm going to bring the camera closer to the monitors that I have here and allow you to visualize the images that I'm seeing. So an electron microscope will produce an energetic beam of electrons that will then impinge on the surface of the specimen. So I'm going to turn on that electron beam right now. The image that you will see that will show up on the left-hand side, which is visual now, would be the fractured surface of that specimen. And I'm going to zoom in to various places. And the idea is for us to understand the microstructure of that surface, looking for structures that may potentially betray the properties of this material. So one of the properties of a bioceramic like this would be that they would have sufficient tensile strength that they will hold to the bone and reinforce that structure. So here what we see is a needle-like structure of the fiberglass. The fiberglass is approximately 10 microns in diameter, and they're fairly long. They're about several millimeters long. Now, not only does this material have fiberglass in them, they also have these grains that you see, which are calcium phosphate in nature. And the reason for that is because bone is made up of hydroxyapatite, which is calcium phosphate, as its base components. Now, one of the things that you can do with an SEM is you can also look at the elemental speciation, what types of elements are present, and that is run through a process called energy dispersive X-ray spectroscopy. And so we will then perform that specific analysis. And here I'm going to collect spectral data, and you will see these curves that show peaks in them that is red in color. And I'm going to pan that camera a little bit. And what this is would be the X-ray signal that's coming out of that surface that is scanning right now. We can identify what these peaks mean. Each of these peaks are characteristic for a specific element. And so if I click this button that says peak ID, then it shows that there's calcium. There are 2 peaks of calcium, phosphorus, silicon, some sodium, oxygen, and carbon. And that's what's expected of this surface. Now, the other thing that one can do, in addition to just understanding the element, is to actually map out the surface. So one can generate then a elemental map of the surface that we are looking at, and that would look something similar to this. Let me bring the right slide. Yeah, so here, phosphorus is colored greenish. I hope you can see this. I'm going to expand it a little better. And notice that this ball-looking structure has both green and red is assigned to calcium, as opposed to the color blue, which are assigned to silicon atoms that predominate what's on the fiberglass. And so that's how this specific instrument is used, or at least one of them. You can capture many images and understand the adhesion of this fiberglass to the plastic substrate or matrix, and also understand the number of pores or voids that's present. And all of this will impact the physical property of the material. So I'm going to switch over to my slides now. And as I do that, I'm going to play a short video for you of the laboratory. So I'm going to share my screen. And share my sound like so. So Elon Musk, who's the founder and CEO of SpaceX, on his interview with 60 Minutes had said this, and I quote, "It's important to have a future that's inspiring and appealing. There has to be reasons why we get up in the morning and you want to live. Like, why do you want to live? What's the point? What inspires you? What do you love about the future? If the future does not include being out there among the stars and being a multi-planet species, I find that incredibly depressing if that's not the future we're going to have." So I think this would be the background or the backdrop of what we'd like to do today, this morning, as we talk about careers and career pathways in science. And my journey started, in fact, from my Lola's kitchen. So my Lola is shown there. She's the lady in the middle of that picture. This was taken right after my high school graduation. And I pretty much grew up on her side. And my Lola is a very good cook. And I remember when I was little, I would be asking all those silly questions, like, "Lola, bakit maitim yung puwet nung palayok pag nagluluto kayo dyan sa dirty kitchen? Pero pag doon kayo nagluto sa gas stove, hindi naman maitim. Bakit ganon?" So sasagutin niya, she will answer, "Well, that's why it's called a dirty kitchen, right?" And then I would interject, bakit yung matigas na bigas, pag nilagay mo sa boiling water, then it gets soft. It becomes soft. Pero naman yung itlog na malambot at pag nabasag natatapon, pag nilagay mo sa boiling water, tumitigas. Bakit ganon? Sabi ng lola ko, "Well, ewan ko, pero hayaan mo na, basta't naluto yan, masarap din yan." So she's a really good cook, and she the best dish that she prepares for me, at least, was the arroz valenciana. And up to this day, I try to copy her recipe. But unbeknownst to me, I think that's one of the reasons why I pursued this career in science. And so that seeds of curiosity had led me to this path of going through science, through industry and academia. And right now, I'm here at the University of Massachusetts, Lowell. Now, sabi rin ng mother ko that life is just like an uphill battle. It's like climbing a mountain, right? And I said, okay, well, my wife and I likes to actually hike mountains. And so during this past couple of summers, we've been hiking some of the smaller mountains of New Hampshire. So merong mga 2,000 foot above sea level, 3,000 foot above sea level, and we can make those easy enough in about 3-4 hours, no problem, we summit. But then there's this Mount Washington, whose elevation is about 6,288 foot above sea level. And it took us multiple times, and our first attempt, we got to about, halfway or so. But that didn't really count too much. So we tried again. That was the same week. And our second attempt got us to about 1,000 foot. And you can see in the middle picture right there, kita na yung mga observation posts ng Mount Washington. And so hindi pa rin namin nakuha dahil medyo umuulan na at ginagabi na, so bumaba na kami. And on our third attempt, we cheated. And we took the shuttle to the summit, and there's our picture by the. But the point is that just like climbing a mountain, life can be full of challenges. You're going against gravity. You will bump and scrape your elbows and knees. You get bitten by bugs, but you persevere until you conquer the mountain. So it's a climb. So let's see. 1969 to 1977. This would be my elementary years or even preschool. June of 1969, right? This is the Apollo lunar landing. And so you can see there, I don't know if you can see from this black and white photo that I am wearing. I was wearing the Lunar Lander module t-shirt of Apollo 11. And so at that young age, I already had this tendencies of wanting to become an astronaut and explore space. Cub Scout, about 9 or 10 years old. Somebody told me, this rock is actually a growing rock, a living rock. Okay, so I said, all right, maybe I should take it home. And so I picked up that 20-pound rock, about 9 kilos or so, and I brought it home. But no matter how much water or how much soil and sand I put on top of it, it doesn't really grow. So there you go, right? Very promising science-minded kid growing up through those years. But during the high school years, 1977 to 1981, I actually became a more or less constant fixtures at the Philippine National Science Fair and Quiz. Some of you might have attended this science fair, if it still exists. And so it's both science projects and also a quiz contest on various aspects or disciplines of science. And I was in both. The picture you see here is during my senior year, and this was the last time that I had joined the science fair. And we had a project, a science project, which we demonstrated that you can get a fertilizer, urea, from urine. So there was no supply chain issues here. Just myself and my friend Sancho right there next to me can generate about maybe 5 gallons in one day. So no limiting factor with respect to the raw material, but getting to the urea was another story. That involved actually the use of concentrated nitric acid. And that process, because I wasn't aware of all the hazards of nitric acid fume, that actually caused me to blur part of my eye. And so there goes my aspirations of becoming a pilot and eventually an astronaut, because now my vision is no longer 20/20. That picture right there that's shown is actually the night that we were studying for the UP college admissions test. And so the day after we took the test, and thank goodness we passed. And that allowed me to move over and onto a program in chemistry at UP Los Baños. At UP Los Baños, I took on the project of looking at pesticides in blood under the guidance of Professor Nieva Librojo Basilio. We went to sample whole blood, plasma, and serum from the farmers in Buguias, Benguet. So that was good. It was a free field trip to the mountain provinces to see the rice terraces. And there is a picture of me actually marching for my graduation. Now, after graduating from high school, or college, sorry, I took on my first job as a science research assistant with biotech, working on biofuels program. This is ethanol fermentation and the scale up of bench processes up to pilot level scale. So the instrumentation that you see there are commercial instruments, but we were also developing homegrown tower fermentation systems that Dr. Del Rosario had invented. I spent about 3 years with biotech, but family needs had taken over and financial requirements had made me look for better paying jobs. And one aspect during this time is that we have a lot of opportunities in the Kingdom of Saudi Arabia. So I tried my luck there, and I did get into a very good established company, the Saudi Petrochemical Company. I work as a senior lab technician at their QA/QC for 3 years only. The plan was to remain a little longer. However, the first Gulf War had commenced, and this was when Saddam Hussein of Iraq had invaded Kuwait. Quite a bit of a history lesson for some of you younger generation. But that was about the June of 1990 when he invaded, and the full-scale war happened in 1991. And my parents, my brothers and sisters were very concerned about my safety because we were only about 50 miles away from Kuwait. So we can actually see the burning oil fields in Kuwait as the Iraqi army had lit them up on fire. So I had to come back home and reestablish my footing. I did have plans of going back to graduate school, but I wasn't quite ready. And so I tried again to go out and seek another employment, this time going to Hong Kong. And I worked there as a laboratory analyst for Hong Kong Standards and Testing Center. This is the premier at that time testing authority in Hong Kong that would certify the products that are coming out of China. So chemical, food, pharmaceutical, even toys and electronics, we would certify those for the American and the US market, as well as for the other Asian markets. Now, you will notice that I only stayed there for a year, well, because I got admitted eventually to a graduate degree program, and that's over at the University of Illinois in Chicago, where I was admitted to work under the auspices of Professor Luke Handy. I took on both graduate teaching and research assistantships, which pretty much paid off for the needs of the financial support that I needed to live, especially that at that point in time, I had married my now wife, and we were establishing a family during my PhD years. I finished my PhD in 1998 and had accepted a postdoctoral fellowship at the University of Houston, again working on instrumentation related to surface science. These are very large. So the diagram that you see there occupies an entire 15-foot by 15-foot room. So malaking instrument ito, and it's full of electronic gadgets in it, equipped with analytical systems that allows one to interrogate the various processes that can occur when you slam an energetic beam of ions onto a surface of various types of material. After my 2-year postdoc, I moved on to the University of Alabama, again on an instrumentation level work. I worked as the laboratory manager of their surface analysis laboratory, both taking care of the instrument, doing menial troubleshooting. If something really bad happens, then I call the service engineers. Most of my job here is to interface with the faculty and the research students, helping them with their research that has implications on surface science. I stayed at the University of Alabama for about 5 years, and because my children are already growing and coming of school age, we decided to move to a place with more competitive school systems, and a job opening had come up at the University of Massachusetts in Lowell. And so I decided to accept that position as lab manager in 2006. At that time, the facility or institution that I am currently employed in is still a very small startup of what eventually became the core research facility. And at that time, it's only called the Materials Characterization Lab. It is a complement of several surface science equipment and electron microscopes and analytical systems. But for the most part, it's a one-man show. But over the years, the university had realized the importance of having a centralized shared facility of sophisticated instrumentation. And so our facility had grown into multiple laboratories. In 2017, the job of the executive directorship was offered to me. However, because of the nature of this position, even though it's a higher paying job and a more prestigious job, I politely turned it down because of the nature that it will take me away from the actual scut work of doing research and science in the laboratory with the students and with the faculty and other clients. And so I remained as the director of the characterization labs, at which point it is a much larger facility now than just the initial materials characterization that I initially managed. Here's a structure if you're curious about what the structure is. Core research facility is a centralized facility under the Vice Chancellor for Research, Innovation and Economic Development. That is Vice Chancellor Julie Chen. By the way, the University of Massachusetts Lowell is one of those universities that are predominantly led by women professors and administrators, and it works very fine. The environment is very cordial, very professional. So as you can see in this diagram, I am all the way down at the bottom of this structure, but I'm one of two directors that report to the executive director of the core research facilities under the direct supervision of an associate vice chancellor for industry, partnership, and economic development. The different laboratories under the core research facilities are the following. We have a class 100, class 1000 clean room called the nanofabrication laboratory. I apologize, there's a lot of acronyms on this slide, but just to make them all fit in one slide, these are the various laboratories. We have the New England Robotics Validation and Experimentation Core, a fabrics discovery center that also performs tests on protective personal equipment like masks or gloves and face shields. The materials characterization laboratory is still present, and I am the concurrent manager of that laboratory as well. We have an analytical chemistry laboratory that houses a variety of chromatographs and mass spectrometers, surface plasmon resonance instruments, and a variety of other wet chemistry type of work. We also have a next generation sequencing and genomics laboratory, which currently is very involved in monitoring the COVID cases that are occurring in Massachusetts and in the region, the New England region. There's a variety of other capabilities, a nuclear magnetic resonance laboratory, a lyophilization laboratory. Lyophilization simply stands for freeze drying. So if you've seen one of these frozen ice cream, astronaut ice cream, they call it. It's coming out of a freeze dryer, which is a lyophilization process. We also have a gamma radiation, a fast neutron, and a proton exposure laboratory, all under the radiation laboratory. And we have thermomechanical properties lab. As for my actual sphere of direct influence, being the director of materials of characterization laboratories, these are the colleagues that I have. Part of my responsibility is to hire the appropriate staff that would be fielded in these various laboratories. So I work very closely with a microscopist, Miguel Matos. He's from Puerto Rico. He has about 15 years under his belt working for Intel. So he's a very good microscopist doing focused ion beam and transmission electron microscopy. And he is a favorite among the students here because he's so easy to get along with. Wendy Gavin is a multitasker. She is a pharmaceutical chemist coming out of the pharmaceutical industry. She manages our NMR, our ACL, the Analytical Chemistry Lab, as well as the lyophilization laboratory. So she's like the Energizer bunny. So she runs around and she's everywhere. But she's very professional, an expert in all of the fields that we're in. Jack Lepine is our molecular biologist who runs the next generation sequencing and genomics laboratory. Again, a very smart fellow. He interfaces with many of the pharmaceutical and biotech companies in the area. Delivers amazing results in a very short turnaround period. We also have a brand new facility called the Small Animal Imaging Core Facility, and I had recently hired a manager, Dr. Mingli Hao. She is a neurologist, and she had worked extensively with these types of equipment. And these are preclinical imaging instrumentation that is used or to assess efficacy of certain drugs. For example, for cancer research, drug development, this equipment are used to image how the drug is efficacious in the animal model. So the platforms that you see kind of sticking out of those instruments are simply the beds where the animals would be anesthetized and be then introduced into the imaging chamber for the experiment to be done. Now, as a laboratory manager, I adhere to certain concepts or precepts that guide me in this process. As I mentioned, a significant portion of my responsibility would be to manage the health and well-being of the various laboratories that I am in charge of. So there are many aspects of leadership that I had to demonstrate and perform. Management in terms of the infrastructure, the actual equipment, management of the finances are very critical, crucial responsibilities that I hold. And I consult with all of my core laboratory managers in terms of building up budgets for a fiscal year and reviewing and understanding their revenue stream. The core research facility is a user facility, which means to say we have multiple clients, not only faculty and students of the university, but also industry clients and governmental and academic institutions as well. Health and safety is a very big concern for a laboratory director or manager. So I work very closely with our employee health services. This would be the environmental engineers and safety engineers who make sure that all of the operations that occur in the laboratories are safe and secure and healthy for the entire community. Compliance issues and ethical issues are also of concern to me as a direct manager. And all of this components of laboratory management are built upon the basic scientific platform that a manager would have. So in my case, that will be my science background, my chemistry background, my surface science and surface engineering background that allows me to perform all of these jobs in the various laboratories that are within my scope of responsibility. And the hope would be that we will be able to induce and enhance the career of the faculty that are reliant on our services, as well as to provide the necessary services that our industry partners are expectant of us. I'm not going to go through the other slide just for conciseness of our presentation today, but I'd like now to kind of switch gears and introduce our concept of planning for our career. Dr. Joey Santos and Isagani Padolina had given us some very good, helpful insights into how one can get into an academic or industry positions. I'd like to somehow do the same thing, but maybe on a slightly different flavor, more of a generalized flavor, where I think at a personal level will help us, especially in this time of pandemic, where the COVID is still amongst us and still a problem, but there is hope. And these are two nuggets of wisdom that I had kind of picked up from various individuals, various people, personalities that I have encountered through my career. They are in no way original to me, but these are aspects of attitudes and perceptions of our world and how we fit in that I find are very helpful and has helped me a lot through my career. So the first would be have a thankful heart. And the second is to aspire to leave a legacy of good. What do we mean by have a thankful heart? Well, as you wake up in the morning, you thank for the wonderful sunshine that showers into or through your window, right? That sets us up for a very optimistic day. And that's where thankfulness allows us to be protected from feelings of despair, feelings of distress, especially in crisis situations, such as the pandemic that we're in. Here, I'm simply showing you the thankfulness that I have for all of the people that I had encountered in my academic years. I did mention earlier that my high school teacher had brought me to all of these science fairs and science quizzes in the Philippines. And incidentally, I found that she is also here in Massachusetts. So Dr. J. Contado Miller was my high school teacher at UP Rural High School, who had asked me and told me, Earl, you need to be a chemist. And so I did. And thanks to her, I had progressed tremendously in this career. Dr. Nieva Libroja Basilio was my BS Chemistry faculty advisor, and I had learned a lot from the examples that she had given me throughout my undergraduate career. As I mentioned, I've worked in the field of biotechnology as my very first job, and Dr. Ernie Del Rosario was my mentor, showing me the many aspects of scaling up processes, both the economics, the science, the engineering, as well as the politics of scaling up and getting into the real world business of scientific inventions. I also am very thankful for the guidance of both my PhD faculty advisor and my postdoc faculty advisor, Dr. Wayne Rabelais and Dr. Luke Hanley. who had introduced me to a lot of the instrumentation that I now hold under my belt. Without them, I would not have understood and learned the basics as well as the advanced principles of running all of this sophisticated and complicated instrumentation that one of them you've seen here as the scanning electron microscope. But having a thankful heart generates in us a humble and a learning heart. And that's very true to me. I am personally blessed by all of these people who had come through the years in my academic life. And I have learned a lot from them. Now, not only did I learn from academicians, I've also learned from people I have met in my work, people I've met in the streets, and in some of the other aspects of livelihood. Reverend Mario Talatala was actually a biotech property custodian at the time, and he was one of the very influential people in that institution. He had invited me to many Bible study sessions, and I had learned from him the importance of having a personal witness. Not only do we exercise faith, but we also exemplify faith. John and Therese Bird, who are missionaries from the University Bible Fellowship, had overlapped with me in Chicago while I was doing my PhD there. They had since moved on to the United Kingdom to be missionaries there. I had been instructed a lot in various ministry aspects, and the main concept that I had enjoyed and benefited from John and Therese is the idea that we have to serve others joyfully. And it's so very true that we can only really serve if we serve with a joyful heart. Mrs. Barbara Bow, bless her heart, she's the founder of the Alphabet Nursery School in Fulton, Ohio, where my wife, Lourdes, at the time that she had to go to Ohio, Canton, Ohio, to take on a transitional internship, medical internship. We had our firstborn at that time, and our firstborn was only, several months old, and he had to be brought to the nursery with my wife running errands between house and her work at the hospital. And there were many occasions that my wife had to be called to emergency. And me at that time, I was still trying to finish my PhD over in Chicago. And so Mrs. Bow, out of the goodness of her heart, had given us the importance of taking Elijah, my son, who was a few months old at that time, into her home after the regular nursery school is over. Reason being that my wife cannot pick him up. And so we asked Mrs. Bow, well, Mrs. Bow, we'd like to give you something in addition to the normal tuition because you had been very helpful to us. But she said, no, pay me back by finding another person in need and serving that person. So out of the goodness of her heart, she had shared how we can, in fact, help and serve other people. So the concept of paying forward, right? It's not paying back a favor that you have received from somebody, but paying forward and multiplying that goodness. That brings us to my second point about leaving a legacy of good. Denzel Washington, in many of his very inspiring graduation speeches, said this: well, don't just aspire to make a living, and he's talking to newly graduates, right? But rather aspire to make a difference. So if you are a graduating senior or a freshly graduated senior looking for a job, think about this, that perhaps you should be aspiring not only to just make a living, but aspire to make a difference. This is so true in my life. And this is a set of examples that I'll show you why I think that aspiring to make a difference helps. So of all the many instrumentation that I had been involved in developing as a PhD student, I had left them in good condition, and so many more students had been able to utilize them. You will see that the original UHV system design is still existent on a newer configuration, albeit it's a much bigger system now. But there were at least 10 other graduate students and multitudes of undergraduate students that had benefited from this instrument that I had built and designed during my PhD years at the University of Illinois in Chicago. Similarly, I had made configuration changes to the low energy ion beam system, and it had produced many peer-reviewed publications and contributed papers, presentations for students that I had supervised that are now graduated and in their own right professionals and leading professional careers. A number of my students who had been whom I had served as a mentor are now also professionals. So for example, Dr. Corina Nestorica from the University of Alabama graduated in 2003, and she is now the director of the Advanced MEMS research at Fujifilm. Students who were at the University of Houston at that time, Dr. Sangmin Lee, is now the CEO of Outermost Technologies, which is a contract laboratory in Sunnyvale, California. And he would actually occasionally send me some of his clients that he cannot fulfill their analysis requests. And so we collaborate and we enjoy each other's camaraderie. I'm going to kind of skim to some of this and maybe mention that James Gallant and Jessica Coate are non-chemistry majors. They are rather biology master students at the time. James had finished in 2016 at UMass Lowell, and Jessica as well, just last year. Both are biologists that brought in very interesting specimens that are fairly new to me. They are in a research group that looked at invertebrates. So James is involved in looking at metal distributions on the claws. So these are the, ano bang Tagalog nito? Sipit ng mga bugs. So this is a whip scorpion that he's holding in his hand. And he would be looking at the different speciation of metals that are present that can reinforce the structure of these claws. Same thing for Jessica. Jessica is our tick lady. So she looks at deer ticks to understand also the presence of various elements on their snouts. And so I had this series of students. This is just a small sampling of the many different students that I had encountered through my various appointments in different universities and institutions. But these are what I consider my stars. These are my rewards. This is the reason that I am in an academic setting and not in an industry setting, because I wanted to work closely with students to inspire and help them go through their career choices and usher them to their professional careers. So now, what about you? You who are in this presentation, what are your stars? Let's reach for your stars. So how about this? So I usually hold, oops, I just lost my place. Sorry about that. This is probably the most important slide. I will go back to this. And that. I usually hold summer internships here in my laboratory. And so this coming year in 2022, I decided that we will hold one position for an international student. And so we have an opening, and I would invite you, if you are a graduating senior or at least a one-year graduated senior in chemistry or in one of the allied sciences or engineering programs in the Philippines, to apply to this 2-month immersive practical hands-on training here in my laboratory. And we'll be looking at various techniques and problem solve some of the real world specimen that I encounter here in the laboratory. So please turn in your applications by simply emailing me your statement of career goals, an essay of how this internship will help you in your career. And guess what? You need to also submit a video clip of your Tala Dance Challenge, because we are reaching for the stars, right? So I'd like to see a Tala Dance Challenge video clip included in your application process. By the way, this is a funded program, 80% reimbursement for your international travel, board, and lodging. And with that, I think I need to close. Mapapalo na ako ni Tita Lani. Back to you, Tita.
Thank you, Earl, for that very stimulating presentation. Thank you for showing us the inside of a laboratory. We saw how your work has touched so many lives. You have mentored budding scientists, and now you are inviting one more scientist to come to your lab. I'm sure you have generated a lot of thoughts and questions among the attendees. Now, Earl will answer the questions after our second speaker. For now, you may type in your questions in the question box. So now let's go to our second speaker. She's Dr. Ruela Talingting Pabalan. She earned her BS in chemistry degree from Uplb in 1993. She was also an active Camsock member. After a short stint as a junior chemistry faculty member, she went to the University of Texas at Austin for graduate school, where she graduated with a PhD degree in physical chemistry. She then joined Rhodia. It's an international specialty chemicals and materials company, which is now called Solvay. That is where she has stayed since, now for 21 years. She has held several positions in various sectors of the company, from the laboratory to technical management, and now she's involved in business and corporate affairs. So from a bench scientist, where she was awarded 14 patents by the US Patent and Trademark Office, to leading projects and now managing strategic technologies, she has done it all. She is currently a part of a team that performs assessments of innovation proposals for corporate funding. And just like our previous speaker, Ruela is also married to a Camsock alumnus, Joey Pabalan. So there's some chemistry within Camsock. Please join me in welcoming our second speaker, Dr. Ruela Talingting Pabalan, as she shares her journey in innovation in the chemical industry.
Thank you, Lani. Okay. All right. I hope you're seeing my slides. I think I was trained well by our Brad Rey. Thank you so much, Lani, for that very generous introduction. I feel like I'm a golden ticket. Thank you. Good morning, everyone. Good morning, Asia and the Philippines. Good evening to our North America. Good evening to my kids. Thank you for joining us. For this seminar, I would really like to present to you critical roles of scientists in innovation. it is applicable for a chemical company or a pharma company, but I think you can extrapolate it to other types of businesses, right? So let me present innovation as a journey from conception of an idea at strategy until you actually make money. Okay. All right, so this picture is probably familiar to a lot of you. This is the 5th Solvay conference held in 1927 in Belgium. For your information, these type of big conferences still happen to this day. So why is it interesting, this picture? It is because 19 out of 29 attendees in this picture are Nobel Prize winners. It is in these conferences where new ideas are thrown. They're challenged, they're defended, they're distilled. And it was also in this particular conference when the newly formulated quantum theory was discussed. And there were disagreements between Bohr, so this is Bohr, Schrödinger, Heisenberg, de Broglie, and Einstein. And they were entities, they were talking about entities such as electrons. And Bohr was saying that, oh, electrons had only probabilities if they weren't observed, which Einstein argued, saying, no, everything exists with or without observation. And prompting the infamous line from Einstein saying, hey, Bohr, God does not play dice, which Bohr contradicted right away, saying, Einstein, you can't tell God what to do. So that was quite an exchange. What is important to note that discussion of new ideas around experts is very important to get the best of any new ideas. And then number 2, the proponents of that new ideas should have the courage, and they have to be accepting of the challenges because it is the avenue to its success. All right, it's easier said than done, as you see, because pride always gets in the way for brilliant scientists, but you have to pay attention to that. Anyway, my point is a long-standing company like Solvay stays in business because it believes in innovation, in collaboration, and getting the best solution for a problem. So let's walk through the journey of innovation together, and maybe I can sprinkle my own tales of experiences along the way. All right, so my mom was a licensed chemical engineer, and she graduated from University of San Carlos in Cebu a couple of years before I was born. I have aunts, cousins who are chemists. I have a dad and a brother who's an engineer. My sister is a therapist. So I did not really question what I would do as a chemist, yet nothing was really clear to me on where I would fall in what they call innovation or research. So I am so glad that I have this opportunity to share to you what I know. And I hope it will shed some light and guidance to our college students, new grads, or graduate students. So in any company, innovation is the key to growth. An innovation is defined as an idea that has transformed into a practical reality. For a business, this could be a product or a process or a business concept or combinations thereof that had been activated into the marketplace and produce profits and growth for your company or your organization. All right, so where do we belong? Where could we find a place? Where will our training lead us? So let's take a look at this circle, right? And innovation, okay, so for any innovation, for it to succeed, it must start with the customer so that it will end up at the customer. So I'll repeat, an innovation should be born with the customer in mind so that your eventual output will be accepted or bought by a customer. So in this stage, as you can see, the customer says what's needed. A strategist will pick up that need. Then it goes to our research folks. And once it gets accepted, then the scale up and production happens, and eventually it gets to the customer. So that's in a nutshell. So let's go through it one by one. So customer need. So who is this customer and how do you talk to them? How do you access them? So, well, you do it in different forms, from directly calling and talking to them. You send surveys. I'm sure you have filled out these surveys, especially in this digital age, or you can brainstorm among experts within the company. However way you talk to them, your goal is to find that need, to define that pain, and to translate it to a probable solution. So you have to ask difficult questions. You describe the need. What do you currently use to answer that need? And what is the desired improvement? And do you really need that improvement? For instance, they say, okay, I want a car, right? Do they really want a Mercedes-Benz or a Toyota will suffice? You have to define that. So, and then ask the benefit of that solution to them. So let me give you an example of an innovation. So in the past, a feasibility study revealed that moms would like some kind of an improvement of a diaper, right? So you know what a diaper is. They want that when it becomes into a toddler, they use a diaper that is ready for potty training. But moms were very specific. They said, I want my toddler to have that feeling of being wet when they pee on themselves. But then in actuality, the diaper are still keeping the child dry. So something like a fake wet or wet feeling integrated into a diaper. And digging further, they even found out that this need was so intense that moms were willing to pay an added premium for such a special potty training diaper. On a personal note, when I learned about this problem, it was the same time when my babies were toddlers and I was also using diaper. So when I opened and dissected diapers when I got home, it made me appreciate the complexities of the design of the diaper, the physical chemistry behind such a practical product. I invite you to do the same thing. Now, I didn't know that such layers exist and each of the layer has its own function. And yes, I agree. I would pay for such a premium diaper. At any rate, when you're a fresh graduate and you go and work, you never know about the origins of the beginnings of your project. But knowing this piece of information would serve both as a compass and an inspiration for your work so that you just don't focus on the chemistry part of it. So let's go to the strategy. Okay? So what happens after you know this need? So I actually learned this story many years ago that this huge diaper company wanted to grow their business from a normal diaper to a potty training diaper for the toddler. But then there was this absence of the wet feeling, right? That the moms expressed. And so they really thought about what could be that solution. But then if you're a strategist, what I can tell you is really when you're coming up with a solution, it is very important that you need to learn two things: the value and the competitiveness that you bring. So what is value? Value is like your potential business. How big could you get without knowing a lot of what it will eventually cost? You must have an idea of what that potential business is from the onset. And the other part, the x-axis would be competitiveness. If you develop that particular technology, will your company be competitive enough? Can you put in enough uniqueness into the technology so that people are really willing to pay? Why is that important? A right decision at the onset of the project is actually the cheapest part of the entire process. If you can kill the project very, very fast without it becoming a long-standing, no output project, that will be very, very helpful for the company. Let me tell you a short tale of the ugly baby. So I don't see you, but have you seen an ugly baby before? Probably you can say, well, I have seen ugly baby of somebody else. But have you really thought about your own baby as being ugly? I don't think so. So that means if you can progress with a baby or your project, and it was not conceived very well in the beginning, it's an ugly baby. But you don't know that it's an ugly baby. Only other people sees it as an ugly baby. So at the very, very onset of the project, it is very important to know which is an ugly baby or which is going to be an ugly project. I hope that's clear enough, okay? So let's go to the research phase. So the research phase is the brains of the development. This is where everything happens. Being a scientist is both being an honor and a responsibility, just like Miss Universe, right? Most scientists are up for the task. Most are endowed with the brains, the astuteness to carry on the task. Typically, if you're a scientist, especially if you're an entry-level scientist, you will start at this part of the innovation. A project is given to a research group. It comprises a scientist. You will be given a problem and chosen probable solution. And you are tasked actually to optimize the technology, to develop a way to test it, and to discuss with the customers. And in this case, you comb through a lot of literature for anything close to your technology. And then you reach out to inorganic chemist or an organic chemist so that they can design the chemistries. And then you discuss with an analytical chemist or a physical chemist, as what you heard with Dr. Earl Ada earlier. The analytical chemists are really key to test for the structure, to confirm the structure, and then the performance of your product. Customers will give you specifications, and it's critical for you to be open in your communication and you have a clear understanding of what the target is and how you're going to test to evaluate it. Yet, as a scientist, in addition to the science of the task, you have other responsibilities, as a lot of you probably know. You have timelines, you have deadlines, you have reports to write, safety protocols to follow. And it is very important for you to be accountable, relentless, and always open to collaboration. This is actually where I started in my career, coming out of grad school 20-some years ago. I remember on my first day of work, I met with the manager. On his table, I saw a bottle with white liquid. So we had our introduction, we had a good discussion on the project, and then he gestured me towards the bottle at the end. And then I remember him saying, okay, here's your sample, get to work. And I was like, oh, having had only 3 hours of sleep earlier because I had a baby, I had an infant at the time, it sounded like a nightmare to me. So months and months of work and horrible challenges, I got some interesting results at the end, had some positive directions thereafter. But the key was I collaborated, to get ideas on how to proceed. So let's say, going back to this, after you see a glimpse of positive results, you would say, that's great. I need to sample my customers really, tomorrow, right? But before you could do that, you actually have you have a list here. You have to file the patent. You have to check whether you have freedom to operate. That means check if nobody else has patented your invention. And then you have, sustainability questions. And then you have to register your product or start that process of registering the product. And then you talk to your engineers, talk to your raw material suppliers. How much would your potential solution cost? Because you cannot just sell a product that's very expensive. And then you arrange all these before you go to scale up. So then let's go to the scale up. So as a scientist, scale up is a happy time. It's actually like winning a game against chemistry. It's a bullseye, it's getting a trophy. When your customer expresses that your product works, now that is just a matter of scaling up. That is an amazing moment. It's an amazing accomplishment. It's like an unofficial handoff from me as an inventor and a scientist to a chemical engineer. And most times, although customers need to retest your product, it's always going to be good most times. And then here, the chemical engineer would help you scale it up. They write the process, they write it to the detail, and this process book gets shared to the next phase, which is production. Okay. So production, it's like the end of innovation. So the success of pilot brings the process to manufacturing. And that's where you start to make money for the company. Oh, my mom always said when she was alive, she would say, Ruela, for every dollar the company pays you, you should make $10 for the company or $100 for the company. Wow. I don't know where she, came up with that math, but since she was a chemical engineer, it was a very good guiding principle. You have to sell to make money for the company. Just to give you an idea of the relative volumes of material, in the lab, you have about 50 grams. In the scale up, you have about 10 kilograms. And in a manufacturing, one batch could be about 10,000 kilograms. So a strict quality control is important. And that's where the analytical chemist really comes in. Going back again to our earlier talk, analytical chemists start from even in the research phase. They carry with you during the pilot and then during the production, and they're the gatekeeper of your product. None of the chemicals gets out from the plant unless the quality control gives their stamp. And then here, a couple more people here, the marketing and sales, they're the ones who really, really understand the economics and logistics. And pay attention, they could be a progression for a chemist or a scientist in their career. So other measures of success, not just selling, right? You can license your chemistry and process. You can be an exclusive raw material supplier to a bigger company, or you can be a partner with a bigger company for some strategic reasons, or you can also sell your patents. And anyway, it's making money for the company. So let's go back. So where do you fit? So again, when you're early in your career, you most likely will fall in the research phase, working closely with a more senior scientist and a manager. At this point, gain a lot of experience, sharpen your research skills, know very well the products and raw materials, know the experts of the company, know the manufacturing capabilities. Now, in here, there are also paths for the scientists thereafter. I mentioned earlier about patent. A scientist could proceed to a law degree and become a patent lawyer. I think we have a bride. Larry Ilag is a excellent patent lawyer for us. And you have to have a law degree to become one. You can also be a regulatory personnel. So these kind of folks follow some government imposed regulation into your product. Somebody has to be in charge with that. And when you're a science major, that's an excellent progression. And other progressions could be project managers, technical managers, and they are ready ladder up from being a scientist. Now, if you are an engineer, you will be most useful, of course, in the scale up with much progression to become managers in a pilot plant or managers of a production facility, a manufacturing plant. And it is very, very important that you work hand in hand with the synthesis chemist and the analytical chemist during this time. Another common progression for the more mature scientists, you've been in the company for quite a while, will be business leader or strategist or in the marketing. Here, as you need to know a lot on the core competency of the company, all the key actors on the business. So it takes quite a while for you to get to this part, but it's a really good progression for you if you want to grow up as in the leadership position within your company. So there you go. You have a short-term, mid-term, and long-term. So in summary, product development process is in various stages, right? It may not be as simple and linear as I presented, but I think the spirit is similar. Again, the key to a scientist is a clear understanding of your goals and the discipline to not depart from it. Good communication skills is key, especially to all stakeholders. And you have to respect deadlines. Deadlines are really deadlines. And lastly, the abundant career progression of scientists in a chemical company, from the lab to a business. I captured here, so this is Dr. Ilham Kadri. She is the CEO of Solvay, and she has a PhD in physical chemistry. And that's me and my hair when she visited our lab a couple years ago. And many of our business leaders like Matt and this guy here, they were once bench scientists in the lab. So that's just to show you that we can do leadership from being a scientist. So to acknowledge again, thank you very much to the Uplb Chemical Society, Institute of Chemistry, the Elementa organizers, MEDConcept. I want to thank my family, my Camsock Brad, Joey from 91A, Titanium, our Camsock derivatives, Mark, Paul, and Mary Kate, my batchmates, and all the Camsock friends and IC friends, and UT and Solvay and Uplb. So I want to end up with the story on the diaper. So whatever happened to the diaper? So surprisingly, the solution was to make the baby skin feel cold when they used the diaper. So what they did is to encapsulate this cooling agent, like for example, menthol could be one, and they put it in capsules. And these capsules are actually readily soluble by a little bit of warm fluid, AKA, the urine of babies. So when they put that in the diaper, and then the baby pees in the diaper, these capsules break very quickly. And then these cooling active ingredients are released very, very suddenly. And then the baby would feel that quick burst of wetness or that cooling effect. And that's quite surprising. It's like saying to the baby, that should teach the baby a lesson not to pee on their pants. So That's all. I hope you learned a lot from my talk. And thank you again. Lani?
Thank you, Ruela, for a very enlightening presentation. You not only discussed the bench chemistry done by chemists, but also touched on other aspects involved in product development, showing us that our chemistry training could even lead us to management and generation of patents. We're proud of your 14 patents. We now invite back Earl so that we can address the questions from the attendees. Okay, so here's a question from an anonymous attendee. It says, I would like to ask for pieces of advice. I think this could be from both of you. I have a master's degree in chemistry education. Aside from being a teacher, what else can I be? Can you suggest other employment opportunities?
Let me take a stab at it. So I guess for the most part, it depends on that person's interest. But one field of employment that I can think of would be a technology manager, for example. So a technology program manager, for example, our university hires several of science or other liberal arts degree person in this position. And what they do is they interface with industry clients and have them interact at the science level so that our industry then can come in as a client into the core facility. Also, these technical writers, for example, would be another avenue for a person with chemical education as an editor in a science magazine.
Do you have anything to add?
Yes, those are really good suggestions. This day and age, there's a lot of training for even not just HR, but scientific trainings. And a lot of them need folks who are very well versed in teaching because, you know, when you're a scientist, it doesn't really mean that you can teach. So having that training of very good teachers, you can look for a trainee opportunity in many, many companies.
Thank you. Here's a question for Earl. Is an advanced degree necessary to land a job as a lab manager and succeed in this position?
So the quick answer is it's not necessarily the case. I have hired managers who are coming out of a bachelor's degree program. They did well, although the career ladder may be a little longer than with somebody with an advanced degree. So the entry point would be different in that case. Of course, for a bachelor's degree holder, it is preferable that that person would have a significant amount of experience in that exact position that the laboratory is engaged in. For example, if that laboratory is dealing with instrumentation, you know, specific instrumentation such as microscopes, then that would entail a candidate who has significant experience, probably multiple years of experience, plus an undergrad degree.
Thank you. Here's a question for Ruela. Actually, there are two questions, and they're a little bit similar. So one says, why did you choose a career in industry and not academia? And the other question is, did you ever consider a career in the academe? Why or why not?
Oh, thank you very much. I prepared an answer to that question. It was really serendipitous. Rather than me making a choice, in August 1999, I went to a national meeting of American Chemical Society to present my PhD work I had an oral presentation and a poster presentation. Then a group of scientists who eventually became my colleagues were present during my talk. And one of them approached me in the poster presentation and encouraged me to apply to Solvay. So sometimes life is able to choose for you. After being interviewed by global companies which had offices in the Philippines, and also I wanted to go back in the Philippines, I still ended up in a company in the US. And personally, I think working in academia, at least for a tenure track professorial position, is extremely difficult. My graduate school advisor used to tell me that if I wanted to be a professor, which because I discussed with him, I had to make the correct choices, even beginning in my undergrad. And I was already a graduate student. So it sounded incredibly hard. You know that, Lani. Writing grants, mentoring smart kids, lesson plans, giving so many lectures. To me, it was so daunting. Not that I tried, because the industry position came in before I had even a chance to apply for an academic position. But to me, I volunteer a lot in the kids. So even those teacher positions, they are hard. And I respect all the teachers. So that's what happened to me.
Okay, thank you. In connection with that, okay, for our next webinar, we will have Dr. Diana Aga, who is a professor at SUNY Buffalo. Okay, she can discuss, okay, the requirements, okay, to being a professor at a tier 1 university in the United States. Okay, so join us again in 2 weeks. This is a question for Earl. In most universities, academics are required to publish as a part of promotion requirements. Are you also required to publish? If so, did you find it advantageous to be in charge of the instruments where many publications are highly dependent?
Yeah, thank you for that question. So the quick answer to that is that I am not required to publish as part of my job description or as a criterion for my promotion. However, we are encouraged all the time to collaborate with faculty, and all of the research that had been done with significant help from the core managers, the research, the core staff, are supposed to be at a minimum cited or acknowledged in the publication, if not a full co-authorship. I have probably co-authored at least 15 different papers during my tenure here at UMass Lowell. It is an interest of mine, except that I just don't have the bandwidth to conduct my own research just so I can publish. So I am, for the most part, a co-author in many papers.
Okay, so this is for Dr. Pabalan. Okay, there's a nice comment here. Wonderful presentation, Mom. My question is, what advice would you give recent college graduates who are looking for their first full-time position? I know you have worked within Solvay's hiring process. How can youthful and optimistic students rise above their competition to stand out?
Oh, did he say Mom at the end of the question?
At the start.
Hello, Mark, or Mary Kate. But I think this is my son. So when you're a fresh grad, the very first thing that you want to really think is, how do you rise above everybody else? You don't want to be a dime in a dozen. You need to differentiate. So you need to have a self-assessment and ask yourself, what do I have that not a lot of people have, right? So are you being smart? Unfortunately, these days, it's not just enough. You have to do more than what is asked of you with grades. So you asked, so what did I do on top of being smart? Did I do some extracurricular activities? Did I show leadership? Did I show discipline? Did I show that I could do more than just one thing? In my talk, I said, when you are a scientist, even in entry level, you have to do other things. You know, you have to write reports, and it's the same thing. Whatever, even if you are a scientist or you're a financial analyst, there are deadlines. There are reports to write. There are meetings to go to. So you have to show that you are capable of multitasking. I know a lot of people don't like that word, but you are capable of juggling many things and then ending up with exemplary results. And that's how you show that you are differentiated. That's it.
Thank you. There's more to discuss later, right? Okay, this is for Earl. Okay. Some clarification about the internship programs. If somebody's interested, okay? I'm currently a third-year student taking up BS Chemistry in Uplb. Am I eligible to apply for the 2022 summer internship in materials characterization since I'm expecting to graduate at around May 2022?
Yes, you are. Definitely, I would encourage you and also your batchmates to apply. Yeah. You will be graduating at the right time, and this would be a very good springboard to an actual job. So yeah, do and apply as soon as possible.
Okay, so this is a simple question for both of you. Simple, but let's see. In your own simple words, why chemistry? Start with you, Earl.
Okay, why chemistry? Well, I did mention that I grew up beside my Lola, right? And cooking, so I like cooking. I'm not a good cook, but I like cooking. And in cooking, there's a lot of chemistry, I find. So that's what brought me to chemistry.
Don't they say that chemistry is like cooking? You just don't lick the spoon in chemistry?
That's right. Or you're in trouble.
Comments, Ruela?
Why chemistry? Well, I have an honest answer and an official answer, but I think I'll just do the the official answer is that's what UPLB offered to me, so I took it. But really, the honest answer was I think my aunt is hopefully listening because I invited her. So my aunt, Ruela Talingting Pabalan, is a BS Chem in college. And she said, I took BS Chem and you can take it too. So she said, put BS Chemistry in there, and had no idea what that would lead me. So here I am, Auntie Lorna. Hello, thank you for watching me. And my mom is a chemical engineer, or was a chemical engineer.
Okay, thank you. Now, here's also for you. How did you make the transition from a scientist to marketing?
Oh, as I've said, my life has been a story of serendipity. You know? About 10 years ago, my old boss moved to another position. And then he came to me and says, you should manage the group when I leave. So Earl and I talk about this, you know, getting yourself out from the lab when you're a scientist, that takes like pulling a molar teeth out of your mouth. So that took me out of the lab for the very first time and brought me to a leadership position. And then from then, it's just a domino effect, you know, from a lab manager to a portfolio manager to a technology scout. And then at the end, the company said, I think, you go to our corporate and do some marketing. So they sent me to Wharton to do some marketing classes. So I think you just find a place where, based on your purpose, right? And where you are at the particular time. You know, I also wanted to learn more outside where I was confined before. And to my amazement, you know, sometimes you're just amazed, right? I actually enjoyed thinking strategically and helping science find direction, so its efforts brings a higher chances of success for the company. You know, marketing is not just writing promotion flyers or helping sales. You know, marketing is actually like the sum of those activities involved in directing the flow of production and services until it end up to the consumers and get that dollars into the company. So marketing can start the whole process of actually finding the right goods to target customers and making that decision from the very beginning. So I like it, and I didn't plan for it. I guess, no, it just happens. Serendipity.
Thank you. So this has been a very nice discussion, okay? Information sharing. But let's end with this question for both of you. What is the most useful experience you had in Camsock and UPLB that helped you in your career?
I can start and Earl can end.
Okay.
I would say there are tons, Lani. It's tons. And every time you use this, you don't even know. But one big thing is leadership. We used to have, I don't know how many quiz contests we went, how many Cup 9 we did, how many sleepless nights we did. So dealing with different people. You will meet different people when you're actually outside. You know? In Camsock, there are many people. You know, there were good things and not so good experiences, but we really learn so much when we get out. And you build that leadership role. And so you will learn how to manage those egos and how to manage their expertise and really utilize them up to their maximum. And then when I moved actually to Solvay, I created a foundation where, you know, you talk to our stakeholders, to the community, to the employees, to the new hires, and they were amazed at how easy I did it. And I was thinking to myself, it's just a small snippet of what we did in Camsock. So I'm really, really grateful of being a Camsock, even now. Earl?
Yeah. So the same thing with me. All the opportunities to participate in Kapnayan, in our Camp Quiz. Things that you will never really encounter in the four corners of a classroom had been just a wonderful plethora of various activities. Even the sporting activities were very, very good. It creates a whole person in you by being in Camsock. So I would encourage who are resident members right now to just simply participate, in all of the activities and contribute. It is a very good training ground that you will definitely benefit from. And you will make good use of once you are in the professional field. So go for it.
Yeah, so go wherever you will go join an academic organization, okay? If you're at UPLB, Camsock. Okay, thank you everyone. Thank you for your participation. This has been a remarkable session. And a heartfelt thank you to the speakers for sharing their experiences and for inspiring all of us to go and do something to make our world a better place to live in through chemistry. If you have further questions to the organizers or would like to get in touch with any of the speakers, you can contact us at elementa.camsock@gmail.com. Before we close, we would like to acknowledge Dr. Marivic Laksamana, the Director of the Institute of Chemistry at UPLB, and the faculty and staff of IC for their continuous support. Okay? We would also like to recognize another Camsock alumnus, Mr. Rey Espiritu, for sharing his platform to host the webinar, and to his team from MEDConcept Solutions for the technical support. Thank you, Rey and MEDConcept. So I would like to call on Mr. Rene Jocares, okay, from Brisbane, Australia, to give us a short announcement.
Good day. This is Rene joining you from Brisbane. This topic has been very, very interesting. As a proud grandfather of 2 toddlers, the topic on diapers was truly quite interesting. Now I know exactly the contributions of chemistry into the manufacturing of diapers. The speakers mentioned about getting out of the lab. I still work in an analytical laboratory here in Brisbane, and getting out of the lab, I think that will be a nightmare for me. I simply can't imagine getting out of the lab at all. But anyway, enough for that. I would like to thank our inspiring speakers today, Dr. Earl Ada and Dr. Ruela Talingting Pabalan, for their very insightful topics and contributions to our webinar series. And Dr. Rey, thank you MEDConcepts for letting us use your platform again. It is we are very appreciative of this whole thing. I also would like to thank the Institute of Chemistry and Dr. Marivic Laksamana, and I would especially acknowledge the support of the UPLB Chancellor, Dr. Dean Camacho, for his support of the Elementa project. Again, our next webinar session will be in 2 weeks, Saturday, the 20th of February. It will be the 3rd career pathways for chemistry students and in the academe and research, to be presented by Dr. Diana Aga and Dr. Noel Bautista. Everyone is most welcome to attend. Thank you all for attending this webinar series, and we look forward to seeing you again in the next session. Stay safe, everyone, and have a wonderful weekend.
Ending webinar broadcast in 3, 2, 1.